ride to higher productivity. How one man's innovation provided the missing link for 20th century agricultural revolution. Now, there's a lot of good stuff which comes out of Ireland. Leaving aside the wonderful music, the amazing countryside, complete with soft rain, and some excellent food and drink, including a drop or two of the black stuff, to which I'm occasionally partial. But it's also a country which punches well above its weight in terms of ideas. It's got a reputation for being a smart economy, basing its progress on putting knowledge to work, creating value from those ideas, innovation. Now, that's something you'll find not only in the universities and high-tech companies dotted across the landscape, but also down on the farm. Farming's a tough business. Anyone who watches the series Clarkson's Farm will recognise the multiple challenges that farmers face, battling all that nature can throw at them when she's in a bad mood, plus rising costs, increasing regulation, and volatile markets. It's a field, ouch, where innovation is not just a nice to have, it's essential. And in Dromora, County Down, there's a statue erected to honour a man to whom many farmers, not just in Ireland, but around the world, have cause to be grateful. Harry Ferguson. Now, of course, farming innovation isn't new. It's been at the heart of our progress towards being able to feed ourselves and so move beyond subsistence to doing something constructive with our newly found spare time, like building cities and societies. Think back to your school days and you'll recognise many of the key innovations which enabled the agricultural revolution, increasing productivity to help feed a growing population. The early days were all about ingenious implements. Jethro Tull's seed drill, 1701. Cyril McCormick's reaper, 1840. John Deere's steel plough, 1847. All these and hundreds of other innovations helped move the needle on farming practices. But better implements still face the limitations of power. And that aspect of innovation remained unchanged for centuries. We'd moved on from back-breaking manual labour, but for centuries we relied on animals, primarily horses, to pull or occasionally push our implements. Power was the agricultural equivalent of the philosopher's stone, that secret which would turn base metals into gold for alchemists, or farms, in this case, into more productive units. So, with the advent of steam power in the early 1800s, it looked like it had been discovered. As factories, mines, even early railways were showing, a steam engine could harness the power of many horses. But in an early example of the hype cycle, the promise of steam power failed to deliver, largely for technical reasons. Steam engines were big and heavy, which meant they had to stay in one place with their power distributed to where it was needed by elaborate systems of pulleys and belts and wheels. They were unreliable and dangerous, with an unpleasant tendency to explode unpredictably. For certain tasks, they held out promise. They could plough a simple, flat field 10 times as fast as a team of horses, but their inflexibility limited their application. Traction engines provided a partial solution, since these machines could carry out basic tasks like drilling and ploughing. Though they were often too heavy to work directly on muddy fields, they did, though, have the advantage of power, which could be quickly moved to where they were needed. Set them up on the side of a field, hook them up to relevant implements like ploughs, and put them to work. And when the job was finished, uncouple everything and move on to the next field, as long as it was fairly flat and big. Interestingly, it was the traction engine which inspired Henry Ford to work on transportation. Reflecting on his first encounter with a traction engine on the family farm, he said, I remember that engine as though I'd seen it only yesterday, for it was the only vehicle, other than horse-drawn, that I'd ever seen. It was that engine that took me into automotive transportation. So, steam power wasn't really going to change the farming world, but another innovation was the internal combustion engine. Engineers around the world had seized on the possibilities of this technology and were working to try and come up with a horseless carriage, something which Carl Benz eventually managed to do with his Motorwagen in 1885 in Germany. And it didn't take a big leap of imagination to see another location where replacing horses could have an advantage. John Froelich, an engineer from Iowa, developed the first gasoline-powered tractor, mounting an engine on a traction engine chassis in 1892. Unfortunately, he wasn't able to make the machine in volume, producing only 4 before closing down the tractor business. But others were more successful. For example, in 1905, the International Harvester Company produced its first tractor, and in 1906, Henry Ford invested over $600,000 in research for tractors, building on his growing experience with cars. An early outcome was the automobile plow, a crossover concept using the Model T as the base. Pretty soon, just as in the personal transportation marketplace, hundreds of entrepreneurs began working on tractor innovation. A classic example of what Joseph Schumpeter, the godfather of innovation economics, would call swarming behavior. By 1910, there were over 1,000 tractor designs on offer from 150 different companies. But a key part of Schumpeter's theory of how innovation works is that many of the early entrepreneurs active in a new field like this will fail, whether for technical or business reasons. And there'll be convergence along key dimensions, setting up a technological trajectory along which future developments will tend to run. Now, that was certainly the case with tractors. Key pieces of the puzzle were coming into place, like an ability to deal with difficult terrain by using all-wheel drive, which was offered by John Deere in 1914, or the trend towards smaller and more affordable machines pioneered by the Bull Company. Agricultural shows began to feature tractor demonstrations, which allowed farmers to see firsthand the relative benefits of different machines. And an early front-runner in the move towards widespread market acceptance was International Harvester, with their light and affordable Titan 1020 model. Now, this was a growing market. By 1916, over 20,000 tractors had been sold in the United States. And as with many innovations, once the dominant design has emerged for the basic product configuration, emphasis shifts to the ways in which they can be made, process innovation. And those players, like Henry Ford, with experience in mass production, had a significant potential advantage. His Fordson brand became the benchmark in terms of pricing, and other manufacturers often struggled to compete unless they were large, like the John Deere Company, which offered its Model D in 1923 for around $1,000. Now, Ford had priced aggressively to try and capture the market, originally offering his Fordson for $200 in pre-sales advertising, eventually selling it in 1917 for $750, a price at which he was actually making a loss. Now, Ford understood the principle. He'd used it to open up the automobile market by offering to build a car for the great multitude at a price that multitude could afford. But things were a little more complex down on the farm. At first sight, tractors seemed a great idea, not least because of their running cost advantages. Animals, while a flexible source of power, were also a big cost, since they needed food, shelter, and veterinary services, plus there was an opportunity cost in terms of the land needed to grow their feed, which could otherwise be used for more profitable crops. It took around 6 acres per horse over the farming year. By contrast, tractors ran on kerosene, becoming widely available and at low cost, and they only burned this fuel when they were actually working. Ford's strategy appeared to pay off. By 1923, he had over 75% of the United States market. And yet, only 5 years later, things had deteriorated so much that the company exited the business. What led to this dramatic shift was a series of challenges to which cost advantages based on process innovation weren't the answer. Product innovation once again became a key differentiator. This time the issue wasn't around simply replacing the animal power unit with a mechanical one. It had everything to do with what you connected that power up to. Now, early tractors solved the connection problem with a simple drawbar, essentially a metal stick to which you could attach different implements, which worked fine when the going was flat, the surface dry, the field large and simple. Unfortunately, most farming also involves uneven ground, plenty of mud and rain-filled potholes, trees and other obstacles, and small fields with uneven boundaries. To cope with all of that, you need a utility tractor. Not for nothing was the International Harvester Farm All a runaway success in the 1920s. The name says it all. Having spent a significant amount for a small farmer on buying your lightweight utility tractor, you wanted to carry out much more than just simple row-cropped duties. You wanted helping out with a wide range of construction and maintenance operations down on the farm. And in particular, one innovation which helped endear International Harvester to many a farmer's heart was the power takeoff device, essentially making power available to be hooked up to a variety of different implements. Introduced in 1922, this opened up the market by massively increasing the versatility of the tractor. All manner of attachments, seed drills, rotary cutters, post-hole diggers, snow throwers, they could all be run off the core PTO. Now, we could draw an analogy to today's IT world. Buying a tractor without the ability to attach tools would be like buying a computer without software. Which brings us back to Harry Ferguson, in case you thought we'd lost the Irish connection. Because connecting farm implements to tractors became his passion and the basis for a highly successful business. In doing so, he provided the platform on which so much could happen, much as Steve Jobs, much later, with his smartphone, enabled users to find and deploy the apps that they wanted. And along the way, Ferguson was able to help Henry Ford re-enter and revive his tractor business. Ferguson was born in 1884 in County Down in Ulster, and he grew up in a farming family, though he wasn't particularly taken with the life. Nor was he that keen on school either, dropping out at the age of 14. What saved him was a love of reading and a fascination with all things mechanical, which in the early 20th century was a good interest to have. His brother helpfully opened a repair shop to cater to the emerging motor trade, and Harry joined him, kindling enough focused motivation to study at Belfast Technical College. Arguably, though, his skill set was less around the mechanical detail than in the front office, sales and PR. He persuaded his brother to sponsor him, and he proved adept at motorcar and motorcycle racing. He even persuaded his brother to fund the development of Ireland's first aeroplane, which Harry then learned to fly. Eventually, he set up his own automobile business, May Street Motors in Belfast, in 1911. And one of his first appointments, a 21-year-old mechanic, Willie Sands, proved to be crucial in his subsequent success. Sands was a gifted engineer. He remained with Ferguson for nearly 50 years, working in the back room, helping develop the technologies which built business success. Now, Ferguson was quick to spot an opportunity in the emerging tractor market, and he managed to obtain a franchise for sales and service of the John Deere Overtime tractor, which was being built in the United Kingdom. That gave Ferguson and Sands extensive experience in the way the tractor was put together, the repairs it needed, and the context into which it was being applied. The miseries of the Great War on the home front included food shortages, and problems with imports meant that the British government were urgently seeking anything which could help out with farm productivity, including subsidising investment in tractors. Harry played a part in this when he was given a contract for the Irish Board of Agriculture in 1917 to oversee government-owned tractor maintenance and production records. He and Sands travelled the country advising farmers, helping them set up equipment like ploughs, and through that they developed an understanding of the problems farmers faced in deploying a tractor. For example, soil compaction, caused by the heavy weight of tractors and ploughs of the time, was a common complaint. All of this honed their skills at repairs and improvements to the current stock of tractors in Ireland. Their next break came when conversion kits for the Model T car began to appear, which enabled people to create a car tractor. Ferguson took a franchise for the Eros, a kit which involved putting larger rear wheels on the car, a chain transmission, and then installing a bigger radiator to cope with the engine load. And his experience here with farmers paid off. He realised this lighter weight car tractor could solve that soil compaction problem. So he got Sands to design a lightweight plough to go with the Eros. This, the Belfast plough, was the first farm implement bearing Ferguson's name. It was half the weight of a standard plough and crucially used a clever idea for the hitch connecting the tractor to the plough. This meant that the load from pulling the plough was equally shared by all four wheels instead of just the rear ones, and that made it also easier to steer and drive. But Henry Ford was not about to let the tractor opportunity market fall into the hands of conversion kits for Model Ts. Instead, he commissioned design and manufacture of his own tractor with a large, slow-turning engine. He even persuaded the British Ministry of Munitions to purchase 6,000 units in return for setting up a factory in Ireland. This Fordson tractor arrived in 1917, but quickly ran into problems as farmers began to use it. In particular, it had a worrying tendency to flip over on its back if it hit an obstacle. Its powerful engine and the relative lack of weight on the front end meant it could be pulled over by an obstacle or an unexpected drag while ploughing. Nonetheless, its arrival spelt the end of conversion kits and dealt a blow to Harry Ferguson's dream. But he was nothing if not resilient. In true entrepreneurial style, he turned the arrival in force of Fordsons to an opportunity, adapting his lightweight plough for use with the tractor. And in particular, he and Sands worked on the hitch system, so it helped overcome that tendency for the front wheels to rear up. Their design included a clever depth control device, a sort of floating skid, which stopped the problem happening when the plough dug in too deep and pulled the tractor over. This worked well with the plough, but for other implements they realised depth control could be enabled by the use of a hydraulic lever which adapted to the terrain. So, putting all of this together led them to a system which worked on a variety of implements, including disc harrows, cultivators, and ploughs. In 1925, Ferguson was granted a patent for this three-point hitch, and it became the basis on which he built his future success. It was a key to unlocking the puzzle of how to connect power to implements and became the dominant design, one which is still widely used today. The significance of this design shouldn't be underestimated. Even though other factors help contribute to the major increase in agricultural productivity, like fertilizers, better seed strains, and environmental management of pests, the importance of completing the mechanization cycle is central. Yes, you can replace horses and mules with machine power, but you can't plant the seeds or distribute the chemicals unless you have the means to connect power with application, which was the problem that Ferguson did so much to solve. So just when it all looked promising, the market weather changed once again. Another shift, again triggered by the business strategy of the Ford Motor Company. After years of making a loss, the company decided to exit the tractor market in 1927, choosing instead to concentrate resources on their new Model A automobile, which left Ferguson with no market for his Fordson fitting plough. So he and Sands, as ever, working away diligently in the back room, they developed their own lightweight tractor based on the Fordson design. They included their 3-point hitch, and their prototype black tractor appeared in 1933. And Ferguson then went into partnership with the David Brown Company to manufacture what became known as the Ferguson Brown Model A. Production started in 1936. Unfortunately, disagreements quickly followed, with Brown wanting to make a bigger tractor, and so Ferguson pulled out of the venture. Instead, he took one of his production Model A tractors into Henry Ford's back garden, literally. In 1938, he showed it off and tested it against the Fordson and another tractor from Alice Chalmers at Ford's Fair Lane Country Estate. It performed so well that Ford wanted to make a deal on the spot, and after brief discussion, the two men shook hands. This handshake deal put a version of the tractor, the Ford Ferguson Model 9N, into production in 1939, and it sold over 10,000 in its first year. By 1940, the factory was churning out 150 per day. So all should have been plain sailing. But Ferguson's prickly nature posed problems. He was in many ways a classic example of an entrepreneur, seeking opportunity wherever he could find it and adapting setbacks to become new directions for development. But he was also, according to his biographer Colin Fraser in his book Tractor Pioneer, Ferguson was also someone who combined the extremes of subtlety, naivety, charm, rudeness, brashness, modesty, largesse, and pettiness. And the switch from any one to the other could be abrupt and unpredictable. And he had a penchant for confrontation. He'd hoped that Ford in the UK would start production after the end of World War II, and he wanted a seat on the board. When this was rejected, he threatened to walk away and start production on his own. But his position was weak. What he didn't know was that Henry Ford II, who'd taken over the company in 1945, had discovered that the tractor business was still losing money at a desperate rate. He also discovered that the Ford Ferguson 2N was being sold at a loss to Ferguson for resale to his dealers, an arrangement that cost Ford around $25 million. Not surprisingly, Henry Ford II wanted to stop, and Ferguson was duly advised that 1947 would be the last year of the handshake agreement. Ferguson fought back, putting his own version of the Ferguson Ford tractor into production in 1946 using a war surplus British factory. But competing with Ford was always going to be difficult. In response, Ford introduced a new version, the Ford Model 8N, in 1947, conspicuously missing the Ferguson name from the badge. Ford's engineers had tried to improve and sidestep Ferguson's patented ideas, but the core 3-point hitch and hydraulic system were retained. Although Ford's marketing and distribution muscle backed him into a corner, Ferguson in turn fought back, suing Ford in 1948 for $250 million for infringement of these patents. He eventually won the bitter dispute and used some of the $9.5 million damages to continue to make tractors in the UK. But his attempts at working independently in the US failed, and eventually he merged his business there with the Massey Harris Company in 1953. And then he retired from the tractor business, though he did continue to develop ideas for the world of motorsport, including creating the first four-wheel drive system for use on Formula One racing cars. He died in 1960 as a result of a barbiturate overdose. The inquest was unable to conclude whether this had been accidental or not. A sad end for someone whose passion and drive had helped enable the later stages of the agricultural revolution. But he left a powerful innovation footprint in farming soil all around the world. He's remembered in the tractor brand which bears his name and in the three-point hitch design, which is still in widespread use.